Hello everyone, good evening from my side. My name is Saziye. First of all, I would like to thank Prof. Joe for his invitation to be part of AKC2020. It is nice to be back. I was there in 2013 for my first AKC conference. So today I would like to talk about the part of my PhD work, which focus on support lipid bilayer platforms for investigation of the membrane complex formation and regulation. And of course, I would like to also share my experience in Singapore during my PhD. Before I start, I would like to introduce myself shortly. I did my bachelor in material science and engineering at Anadolu University in Turkey, and then I moved to Singapore to do my PhD. In the group of Prof. Joe. And after completion of my PhD, I moved to Switzerland to do my postdoc research in the group of Professor Paliwan at the University of Basel. Now I currently relocated to Newcastle during the pandemic. My research interests basically cover the development of the model membrane platforms, which are composed of either lipids or the amphiphilic block of polymers, and their conjugation or interaction with the different membrane proteins for application like drug screening platforms or biosensors. If you are interested, you can also go and check my publication from my Google Scholar account. So during my PhD, I was interested in the complement system, basically a protein network, which compose of various plasma proteins, and they can be activated directly by pathogens, either directly or indirectly by pathogens, and create the complement cascade, like different protein-protein interactions. And this activation can happen during the different pathways. And as you see here, the whole initiation of the different pathways also includes the different proteins. And once the complement system is activated, there are four main functions, which includes lysis of the infectious organisms, activation of the inflammation, opsonization, and immune clearance. And for my PhD, I was interested to explore how lipid membrane affects the protein absorption in the context of initiation of the complement system, amplification, and termination and the regulation as well. But in this talk, I will only focus on the termination and regulation of the complement activation. So, in order to test also monitor the effect of lipid bilayers on the complement activation, we created the support lipid bilayer platform by using the solvent acid lipid bilayer method, SALP method, which was invited by our group. Basically, we dissolve the lipid molecules in the water miscible organic solvent, and we gradually exchange with the aqueous solution. And end of the 100% the exchange, we ended up getting the deposition of the lipids on the solid support in the forms of lipid bilayer. And we monitor the formation of the support lipid bilayer by using the QCMD method. Basically, you detect two different signals, either resonance frequency and the energy dissipation. Frequency is associated with the mass. Energy dissipation is associated with the viscoelastic properties of the absorbed mass on the sensor surface. Here is the typical QCMD measurement signature that we obtained from the SALP method. As you see, change in the frequency and the dissipation is a function of the time. And the final frequency we obtain around -26 Hz, and dissipation is around very close to 0, which represents the values for the support lipid bilayer formation. So once we have the support lipid bilayers, then we study the interaction of the proteins to form membrane complex on the support lipid bilayers. So in this case, what we did, we created like three different support lipid bilayers, which has a different membrane surface charge. And here in the figure, DOPC represents the neutral charge and DOEPC represents positively charged, and the memory surface, POPG represents negatively charged. And then we sequentially injected the different, the memory complex components. And as you see from the results that once we inject the first component, C5B7, mixture of C5B6 and C7, and you see the decrease in the frequency and increase in the dissipation, and for the further addition of the C8 and C9 is the similar. And we clearly show that here memory attack complex preferentially forms at the negatively charged support lipid bilayers. So once we have this, the memory attack complex on the negative charge support lipid bilayer, the next question is whether we can regulate or inhibit the formation of the MEC, memory attack complex on the lipid bilayers. And we apply two different strategies. First, we incubate inhibitor plus the first component of the memory attack complex and see whether we reduce the binding of these proteins on the surface. Or second approach, whether we decorate the membrane surface with this inhibitor and block the components of the memory attack complex. And from the first strategy, when we incubate them together, what we see is very interesting. At lower concentration of the vitronectin, what we observe, it prevents the insertion of the C5B7. And at the higher concentration of the vitronectin, what we observe that higher amount of binding, which means that vitronectin compete with C5B7 and interact with the surface, memory surface directly. At the second strategy to decorating the first with vitronectin, then addition of the first memory attack complex component, what we see, this vitronectin interacts with the surface concentration dependent manner. When we have more concentration of the vitronectin, we have more on the surface as well, which also inhibits the absorption or absorption of the first component on the surface directly. So, and what happens for the C8 and C9 addition, sequential addition of the C8 and C9, irrespective of the strategies that we apply, and both C8 and C9 protein absorption decreases as a function of the vitronectin, which means that if we have more of the vitronectin in our on the surface, then we have less chance to get the memory attack complex. So the conclusion, if I think of the fundamental aspect, basically we develop a quantitative approach to study in situ real-time assembly of the complement proteins and their regulation on support lipid bilayers. If we think of industrial aspect, with such information, we can develop immunocompetent liposome formulation, or we can use support lipid bilayers as a drug screening platforms, and we can also test different complement inhibitors that design for specifically to memory attack complex. So with this opportunity, I would like to thank my professor, supervisor, for his support during my PhD. He was always there for me to solve also my paperwork. He was very supportive, and scientifically also he was there for any question that I have. I'm really grateful to Prof. Joe. And also I would like to thank my co-supervisor, Professor Walter. He was also very supportive. And I would like to also thank my working closely colleague, Professor Josh. We were there together. He was the first PhD of my Prof. Joe, and I was the second. We worked very closely together. It was nice to work with you, Josh. I know that you are also attending in this conference. And I would like to also thank all the ETS group members. They were really so supportive and helpful. They will be there for if you need any helps without thinking. So a little bit fun part. when I was looking my folder to see the photos that I have, and I found only one photo from the AKC 2013. Only you can see it from the folder that I have. And I and all ETS members, we worked really hard in Singapore while we were doing our PhD or master, but we also had, of course, fun outside the lab. We work hard, but we also had so much fun all together. And it's also a really nice experience that I get close to with all of my lab mates, and this is very important for me. And they became my close friends as well. Most of us right now in different places and like continue our career, but I think thanks to being in Singapore, like I made a lifelong friends from all over the world, and we are still like well connected, and we do talk regularly. Whenever we have a chance, also we meet face to face. Hopefully, after the pandemic, we will have another chance, maybe to meet again in Singapore or in Korea or somewhere in Asia. And again, with this, I would like to thank you for your attention. If you have any question, please do ask to Prof. Jo. Thank you.